Okay, so I set you June 2005 over the Christmas period, and there's two questions I think are a little bit more challenging. So here's the video solution for question 4, which is the first of the more challenging questions within the paper. So it's given us this curve, and it's this polynomial. Then it tells us where it touches at 1, 0 and cuts the x-axis at point B, and it says use factor theorem to show that x minus 3 is a factor. Well, factor theorem says that if we sub in the value of 3, then this should equal 0. Yeah? So part A, I'm going to write my polynomial P, subbing in 3 is equal to 3 cubed minus 5 lots of 3 squared plus 7 lots of 3 minus 3. So 27 minus 45 plus 21 minus 3. Well, the minus 45 and the minus 3 give us minus 48. And the 27 plus the 21 give us 48. So that does equal 0. Now, is to show that question. Yeah? So I need to write my statement. Therefore, x minus 3 is a factor of px. Okay. So, next part of the question. And then it says, hence find the coordinates of B. So, B is this point here. Now, if we know it touches at 1, 0, and we conclude there's only over one point it intersects the x-axis, then it must intersect at the solution for this bracket, which is 3. It's only one mark, so all I need write is A, I, and then 3, 0. Yeah. Okay, then it says the point M shown on the diagram is the minimum point of the curve with the equation, and then it says find dy by dx. So bi dy by dx. Now, to differentiate, remember, we multiply by power, take 1 from the power. So this x cubed up here is going to equal 3x squared. Then the 2 times by the negative 5, that's negative 10x. The 1 times by the 7 plus 7, and the x drops off. So that's dy by dx. It then says, hence, determine the x-coordinate of M. So, for the x-coordinate of M, dy by dx must be equal to 0. So, I'm going to start with that. Dy by dx equals 0 at stationary points. A little note to myself. And then I'm going to say, okay, well, 3x squared minus 10x plus 7 equals 0. Now, if I can factorise this, I can work out both of the stationary points. 3x and x, and then I must have 1 in 7. 7 in 1, because the 3 times by the 1 and the 7 will add to 10. Negative, negative equals 0, don't forget. It's really important. So my x values, x equals 7 over 3, x equals 1. Well, x equals 1 was this point shown to us here. Yeah. And clearly the maximum. So the minimum here at M, x equals 7 over 3. Okay. So the next part of the question then says, find the value of d squared y by dx squared when x equals 1. So the first thing I'd always do with this type of question is I always write my dy by dx. So we're now moving on to part C. Let's label the question. dy by dx. Now copy it very, very carefully. 3x squared minus 10x plus 7. Okay, so now I'm going to say, okay, well, I'm going to do the second derivative. Again, I'm going to multiply by the power. Take 1 from it. So 2 times by 3, 6x, and then 1 times by 10 minus 10. And now what I need to do is it said when x equals 1. Okay, well, the second derivative in this case equals 6 lots of 1 minus 10, which is equal to minus 4. Yeah? And that's all it's asking me. We do know that that is point A. Yeah? And it's worth remembering, because it's negative, it would be sad. Yeah? And there for maximum. Yeah? But this bit is not needed for this question. Yeah? Also, if you were writing your statement and it was required, I'd also encourage you to write minus 4 is less than 0. Yeah? Okay. So, last part of the question, part D, is saying, okay, find the integral of this with respect to x. So integrate this with respect to x. Hence determine the area of the shaded region bound by the curve and the x coordinate. Yeah? So first I'm going to do this. At this point there's no limits, so I need to remember two things. I need to remember plus c, I need to remember my rules of integration. So I'm going to add 1 to power and then divide by it. So I'll come on to a new bit of paper. I've written out di, we've just discussed it. When I integrate it, I need to make sure I add 1 to the power and then divide by the new power. Having this written means I can write equals nice and clearly and then just go straight into my integration. So that's x to the 4 over 4 minus 5x cubed over 3 plus 7x squared all over 2 minus 3x. Now, at this stage I've got no limits, so I must have my constant of integration plus c. Okay, moving into the second bit, dii, it said we need to find the area of the shaded region. Yeah. Now if we integrate between the limits of 0 and 1, yeah, we will find that. So I need to tell the examiner exactly what I'm doing. So I'm going to integrate between the limits of 0 and 1. And obviously I'm integrating the same thing I've just done. Now, again, I need to write equals. Now, because I've now got limits, I don't need my plus c. Yeah? And also, I need to now pop this in some square brackets. So it's essentially just copying what I've just done correctly and then dropping off the plus c and adding the limits to the end bracket. Now, I want to do upper limit, take lower limit. So I sub in 1 to get me going. Shut that bracket and I take away the lower limit. Now, because all of these have x terms, if I sub in 0, I'm going to get 0. So it's absolutely fine to do that in your exam. Now I need to expand this. So I've got a quarter minus 5 over 3 plus 7 over 2 minus 3. Now that's all quite ugly. I need to kind of put these over the same fraction. Okay, 4, 3 and 2 will all go into 12. So express that as 3 over 12 minus 20 over 12 plus 42 over 12 minus 36 over 12. Okay, then I can sort all this out. So what have I got? Well, I've got 45 over 12 minus 56 over 12, which is equal to negative 11 over 12. Now, this is positive. You should know that when you integrate something and you're finding area between the x-axis and the curve, and it's underneath the x-axis, the area should come out negative first. Yeah, or the value should be negative. So the area, therefore, area is equal to 11 over 12. And that is this question completed.